Welcome, everyone. All right, let's just jump right in. Today, we're doing a highly focused explainer on the absolute fundamentals, the very materials that literally construct our modern world. And to make sure you get the full, unedited picture, we are covering Lesson 5.1 complete only, metals and nonmetals. Have you ever actually stopped to wonder why a massive bridge can hold thousands of tons of concrete and steel, but, a glass window shatters from a stray baseball? Or why the electrical wires hiding right there inside your walls don't just burst into flames every time you flip a switch? Well, it all comes down to the fundamental physical properties of the materials we use. So today, we're going to unpack these properties, separate the metals from the nonmetals, and reveal the hidden superpowers that make everything around us tick.
But before we get into the heavy science, I want you to try a quick exercise. Take a second and just look around the room you're in right now. Can you spot at least 5 different things made of metal? Maybe it's the legs of your chair, the frame of your window, a lamp, or hey, maybe even the device you're using to check out this explainer. But here's the real question. How do you actually know they're metals? I mean, what gives them away? We usually just intuitively know, right? But scientifically speaking, there's a very specific checklist of properties a material absolutely must have to join the exclusive metal club.
So the most visually obvious dead giveaway for a metal is its shine. Just look at that stunning gold jewelry. When metals are freshly cut or given a good polish, they are incredibly shiny. They catch and reflect light beautifully. And look, this isn't just about aesthetics, though obviously with gold and silver, we definitely use them for that. This luster is actually a core characteristic of metals. If you were to scratch away the dull, oxidized surface of pretty much any metal, you'd find that brilliant reflective shine just hiding underneath.
Act 1. The heavyweights. Now, appearance is one thing, but metals are truly defined by what they can do. Let's look at the specific physical superpowers that make metals so incredibly useful for the heavy-duty, demanding jobs in our world. Superpower number 1? Malleability. Think about the word malleable. It's the property that allows a material to be bent, pressed, or hammered into shape without shattering, breaking, or cracking. Imagine taking a hammer and just whacking a piece of chalk. It would literally explode into dust, right? But if you hit a piece of metal, it just flattens out or bends. This toughness is absolutely crucial because it means metals can hold massive weights and absorb huge impacts without failing.
And you can see malleability perfectly in action right out in the real world. Think of a blacksmith hammering glowing iron into shape. And then picture a massive bridge constructed from that very same iron. Iron is basically the poster child for strength and malleability. It's incredibly tough, and because it won't just shatter under immense pressure, we trust it to hold up our bridges, our skyscrapers, and our cars. It literally bends to our will without losing its structural integrity.
Okay, let's move on to the next superpower and see how this builds our modern infrastructure. This property is called being ductile. Ductility is a material's ability to be stretched or drawn out into extremely thin wires without snapping. Again, if you tried to pull a wooden stick into a wire, it would just snap in half. Metals, on the other hand, can be pulled thinner and thinner, stretching out to create the vast hidden networks of wiring that power our entire globe. Take copper wiring, for example. Copper is the absolute ultimate choice for electrical work, and for 2 massive reasons. First, as we just learned, it's highly ductile. You can spin it into these incredibly thin, flexible strands. Second, it's a phenomenal conductor of electricity, meaning it lets electric currents flow through it with very little resistance. So you get a material that carries power super efficiently and can be bent around tight corners and stuffed into walls without snapping. That is the magic of ductile metals.
Superpower number 3 is a bit more musical. It's called being sonorous. If a material is sonorous, it makes a loud, clear, ringing sound, kind of like a bell, when you strike it. Now you might be thinking, hold on, if I hit a glass bottle, it clinks. And yeah, that's true, glass and ceramics do make a sound, but they completely lack that long, resonant, echoing ring that is the distinct, undeniable hallmark of a metal. A great way to think about this is a drum kit. Crashing a cymbal is a direct, real-world application of the sonorous property. Musical instruments, whether it's bells, cymbals, or even the strings on a guitar, are crafted from metal specifically because of how beautifully they ring and vibrate. When you need a sound to really carry and resonate, you turn to metal, for sure.
Now, before we wrap up our heavyweight metals, I have to share a really fantastic exception to the rules. Generally speaking, metals do not melt easily. They have incredibly high melting points and boiling points. I mean, it takes a massive roaring furnace to melt iron or gold. But there is one solitary rebel in the metal family, mercury. Mercury is the absolute only metal that is entirely liquid at standard room temperature. It's just a fascinating piece of scientific trivia that goes to show nature always loves to throw us a curveball.
Act 2. The counterparts. Okay, let's shift gears. We've talked about the heavyweights, the shiny conductors. Now, let's explore nonmetals. And I really want to be clear here. We shouldn't frame nonmetals as somehow lesser materials just because they aren't strong or shiny. They are just completely different, and they are equally essential to the survival and function of our world. The true superpower of nonmetals actually lies in what they do not do. Many nonmetals are what we call insulators. An insulator is a material that does not conduct heat or electricity well. If metals are the superhighways for electricity and heat, nonmetals are the roadblocks. And thank goodness for that. Without insulating nonmetals covering our electrical plugs and cables, we literally wouldn't be able to safely use any of our technology. They protect us.
So the crucial takeaway here is that nonmetals are effectively the physical opposites of metals. Where metals are shiny, nonmetals look dull and really don't reflect light well. Where metals are malleable and bend, solid nonmetals are brittle. If you drop them, they shatter into pieces. And of course, they are poor conductors of heat, which is exactly why we use them for things like the handles on our cooking pans so we don't scorch our hands making dinner.
But nonmetals aren't just useful for blocking heat and electricity. They are incredibly highly valued for the chemical reactions they have with other substances. Take sulfur, for instance, a yellow, dull nonmetal. We actually add it to rubber to make it hard and durable, which is exactly how we get reliable car tires. Or think about pure oxygen, a non-metal gas that is literally life-saving for patients in hospitals with breathing difficulties.
Let's rapidly fire through a few more of these incredibly specific, everyday uses that keep modern society humming along right behind the scenes. Helium. It's a gas with an incredibly low boiling point, and it's what we use to make balloons float. Chlorine, the absolute unsung hero of summer, killing bacteria to keep our swimming pools from turning into swamps. Carbon. It's a total multitasker, used in filters to purify our drinking water and even in medicines to treat indigestion. And silicon? Well, without silicon, we wouldn't have the computer chips powering the very device you're watching this explainer on right now.
Act 3. The grand matchup.
We've seen the strengths of both sides. Now, let's bring everything we've just learned together to completely solidify your mental framework of material science. Comparing these materials side by side really highlights just how wonderfully diverse our physical world actually is. To summarize the complete Lesson 5.1 dichotomy, in the blue corner, we have metals. They're shiny. They're malleable so they bend instead of breaking. They're ductile enough to stretch into wires. They require massive heat to melt, and they are fantastic conductors of both heat and electricity. And in the red corner, nonmetals. They're dull to look at, their solid forms are brittle and shatter upon impact, many are gases with low melting points, and they serve as our world's greatest insulators. Two totally different profiles working together to build our entire reality.
Which brings us to the end of our explainer. But really, it's just the beginning of a whole new way of looking at the world. The next time you pick up an everyday object, I want you to run it through the test. Is it strangely cold to the touch because it's actively conducting the heat right out of your hand? If you tap it, does it ring with a sonorous echo or just give a dull thud? You now hold the literal keys to decoding the materials all around you. You're basically a newly minted material scientist. So what will you discover next? Keep exploring, keep questioning, and I'll see you in the next explainer.